Namaskar and welcome to the 8th episode of Pustakalya Wala Podcast, where we are going through the book The Nature of Consciousness by Susan Pockett, the EM field theory of consciousness. And we have just started chapter 1, which is on states of consciousness and what data do we have pertaining to this theory with the states of in this field of states of consciousness. And this is what we are going to discuss today. Also, I'm trying to sound nicer so that people actually end up listening to me. So I'm gonna try to be a little faster, maybe less ums and ahs, maybe a little more, little louder, and maybe a little closer to the mic. I don't know how it goes. I don't know. I need some feedback. I need some expertise on voice recording. Maybe I'll learn slowly as I do it every day, but that's where I am right now. Okay, so let's get started. The chapter starts with this question. Can you tell what state of consciousness one is in just by examining their EEG? And the answer given at the start of the chapter is a resounding yes, sort of. Because it's really segregated. The waves are kind of segregated very nicely between the waking states and the wakeful, sleep, and dream. These three states, I think that those are the three main ones. Let me check. Yes, these are the three initial main ones. Basically, waking and light sleep, deep sleep. And then there is the fourth state. And then there is meditation as well. So there are some different types, but we are not going to cover that in this podcast because I haven't read them yet. This is just the first part of the first chapter. So, fast, small amplitude waves are associated with wakefulness. Fast as in quick, as in higher frequency. Higher frequency, lower amplitude waves are usually wakefulness, right? And slow, lower frequency, high amplitude are usually sleep, associated with sleep. The deeper the sleep is, the slower the frequency and the larger the amplitude is. That's according to the data, as they have been studying for a long time. The interesting point is waking and dreaming have very, very similar EEGs. It's actually indistinguishable apart from the fact that in one of them you have a rapid eye movement. In case of dreaming, usually, that's also not absolutely certain whether non-REM sleeps have dreaming or not. New evidence shows that it does. So there is no... Both of these states are called gamma, associated with gamma waves, waking and dreaming. They are something called desynchronized EEG, which is again low amplitude, high frequency. And it kind of, this is something new I learned. The first real new thing I learned was this. These gamma waves look like something called 1 over F noise. Let me repeat, 1 over F noise. It's also called the pink noise, and it occurs in nature in a lot of different places. Ocean waves, thunder, and all those things are associated with this 1 by F. What is 1 by F noise? What is pink noise? If your usually the if all the frequencies in your whole spectrum have same amplitude, it's called white noise, similar to white light. In case of the sun, the light that comes from the sun is called white light because all the frequencies of the light waves have the similar amplitude. There is no segregation between different frequencies. That's why the light is white, even though it looks yellow because of the atmosphere. If you go away from the earth into space, it will be white light. It will be equally distributed in all frequencies. That's what white noise is also. All the frequencies of the sound are the or whatever the noise is, whatever signal it is. Noise can be in any signal. If that is white noise, what is pink noise? Pink noise is where lower frequencies have higher amplitude and higher frequencies have lower amplitude. That's why most of the amplitude is towards the lower frequency side, which is similar to infrared, the red spectrum of light. Red is lower frequency, blue is higher frequency. That's why this noise is called pink noise. And the opposite of that is blue noise, where higher frequency is higher amplitude. So that's why it's also called 1/f noise, because the amplitude or the power of the signal or the noise is inversely proportional to the frequency. And if you listen to difference between white noise and pink noise, I'll add it here. Listen to white noise. Listen to pink noise. I'll add it later on, but I just left some space and you can hear it right now. Difference. Pink noise is more deeper. It kind of also sounds like a thunder storm raging outside. People say you can sleep in this sound very soundly. You can sleep with this noise very comfortably. And some people say it's because when we were hunter-gatherers, if there was a thunderstorm outside, there was no chance of any predators coming and attacking you at night. So you would sleep very soundly because you had no danger from any. And I think it's a hypothesis. I don't know if it's actually true. So this is pink noise, and it's similar to the gamma waves are actually similar to this. Very interesting. This is something new I figured out. I saw a number file episode, not a number file episode, 60 symbols episode on this before making this podcast. So now there is no EEG difference between waking and dreaming states, but there are other differences. One of the differences is in sensory input. There is no sensory input in case of dreaming, but in case of waking up, in case of waking states, you have a lot of sensory inputs, right? Except for auditory. Some people say auditory input is still on in case of dreaming. You must have heard noises from the outside impacting the dream in interesting ways, where a sound really gels into the whole dream very nicely, into the whole story, and you don't perceive it as an outside noise or a noise that is not related to your dreams. Usually long-term memory is another difference. In case of dreaming, there is no long-term memory storage. In case of waking, there is of course long-term memory storage. Otherwise we would all be Memento guy, that guy from Memento. It was thought that only REM sleep is dream sleep, but again, we have discussed this. New evidence shows that that's not always true. Non-REM sleep can also have dreams. But one thing is true, that gamma waves, these are called 40 hertz waves, but they are not always 40 hertz. They are between 20, 30 to 80 hertz. And these are called gamma waves. Why are they called gamma waves? There is, interestingly, there is section in the book called Why is the Name Gamma? And it explains a lot of things about a lot of different researches that happened before this book was written. And it turns out that the mechanism of gamma waves is poorly understood, even with so much research focus on gamma waves. We don't really know how gamma waves are produced, at least in 1999. I should actually update all these things for later on, but we'll see. So that section actually didn't really explain why the name is gamma. Maybe someone else would chime in and tell me why gamma waves are called gamma waves. Maybe tomorrow we will come up with an answer from Wikipedia. Let me write it down. Why are gamma waves gamma waves? Okay. And it's already 12 minutes. We are done for today. Thank you for listening to Pustakalya Wala Podcast, episode number 8. We are not halfway, we are 20% through with the first chapter, and we will continue tomorrow. I'll just add one more postscript to this. According to Susan Pockett, and according to other researchers, it is kind of evident that wherever there is consciousness, gamma waves are kind of present. And that's the case with waking and dreaming states, completely different states in all senses, except the fact that there is conscious experience in both of them. And both of them have this gamma wave function. And that's all. See you tomorrow.